In this problem, we're going to compare the two functions, the sum of the floor and the floor of the sum. Okay, and we're going to see that there are two different functions. In our case here, we want to compute the floor of 1 over k, where k goes from 1 to 10 to the power 9. And we're going to compare the other term, which is the sum of the floors of 1 over k, where k is going from 1 to 10 to the power 9. One key idea that we can have is that we can use what we know from improper integrals, and we can deduce some results. And sometimes when this number is too big, we can make it small, so we can make the problem smaller and we can see what we can get. The question here is compare. That means which one is bigger. Okay, and we can see this one here, that this sum here, if we take k is, let's say k is 3. Okay, so here we see that this one here is going to be the sum, where k is from 1 to 3 of 1 over k. Okay, k in this case is going to be the 1, 2, and 3. So we have the floor of 1, which is 1. Okay, let's put it here, which is 1, plus the floor of 1/2, which is 0, plus the floor of 1 over 3, which is 0. Therefore, this sum here is 1, at least for k between 1 and 3. For this one here, if we have this sum here, we're going to have 1 plus 1/2 plus 1/3. Okay, and the floor here is going to be the same as the sum of the floors. Okay, but if we take a bigger number, but not that big, if we take k as 11, okay, we can see that we're still gonna have the sum of the floors of these numbers, where k is going from 1 to 11, still gonna be 1. Okay, because we can see here that for all k's bigger than 1, okay, 1 over k is gonna be less than 1, strictly, except when k is 1. Let's say k is strictly bigger than 1. So all the inverses is going to be less than 1. And therefore, the floor of 1 over k is different from 1. It's going to be 0. So here we deduce that the sum of the floors of 1 over k, where k is going from 1 to 10 to the power 9, is 1. On the other hand, if we compute the sum of 1 over k, where k is going from 1 to, let's say, 1, 2, 3, 10 is 1 over to 11, we're going to have 3 here. And therefore, 3.0 something. Therefore, the floor is going to be 3. And therefore, these two are different. Okay? Moreover, we can see that using integration that the sum of this series, so 10 to the power 9 is too big. So we can think of this one, this is positive, decreasing, okay? And if we think of this, the function as 1 over x, so this is defined on 1 plus infinity, it's positive, continuous, and decreasing. And therefore, this sum here, 1 over k, where k is going from 1 to 10 to the power 9, is the same as the integral from between 1 and infinity of 1 over x dx. And when we compute that, we get the natural log of x between 1 and x, and we take x to infinity, we are using the definition here. So this is infinite. Therefore, the floor here is infinite. Okay? It's big, and therefore it's different from this one. Okay? I don't know exactly, but between 1 and 11, it's 3. So this means that these two functions are the same, and this one is just 1. This is just 1 for any number bigger than 1. Okay? And this one here, so this is the harmonic series. Okay? And therefore here, if we think of this number, the floor of the sums is going to be bigger. It's getting bigger slowly, but by the end, it will be bigger. Okay? So here we can see that this improper integral, and if we take the floor of an infinite number, it's going to be infinite. Okay? And therefore, these two numbers, this one is bigger. Okay? It's bigger than this one. This is 1. So this one is bigger. And therefore, these two numbers are not the same, and this one is bigger here. Thank you.